Alright, like always, go ahead and pause the video and try this warm-up out. I'm recording this at school, so we'll see if it sounds any better or different. So, now that we're back, remember, describe how the values of cosine x and sine y are related. Again, if you're focusing on cosine x, I'll put this in red. Remember, that's going to be adjacent over hypotenuse. Okay, and if we were looking at sine y, that's opposite over hypotenuse. Yeesh. Using a different slate for this, so it's going to look pretty ratchet. But anyway, take notice they are sharing the same sides, which means their ratios are going to be the same. Okay? So when it comes to their values, we say they are congruent because there's the same side ratio. Boop. Boop. Again, angle of elevation is when you are looking up. Okay? From the horizontal, you look up at an object. In this case, a beautiful bird. Perfect killing machine because it looks like the bald eagle, but nevertheless, you are looking up, angle of elevation. So let's look at an example. Marcus is flying a kite. Yes, kites fly in the air. So Marcus is flying a kite. He lets out 40 yards of string and anchors it to the ground. He determines that the angle of elevation of the kite is 52 degrees. What is the height x of the kite from the ground? We need a picture. Okay. Here's the 52 degrees from the ground, angle of elevation. Okay, the string is 40 yards. Okay, and we need to find out how high the kite's flying. Okay, based on what we have to work with relative to 52 degrees, x would be the opposite side. 40 would be the hypotenuse. Okay, this would be the adjacent, but we're not looking for it, and they didn't give us any measurements for it, so we're just going to ignore it for right now. This is when you ask yourself, what trig function incorporates opposite and hypotenuse? That's right, sine. Okay, now that we picked the trig we want to use, then we're simply going to plug in what we know. Okay, A is 52 degrees. Opposite side was x. Hypotenuse is 40. Okay, the 40 got over here because you need to multiply by 40 to both sides. And this 40 cancels, and you have 40 times sine 52. Let me move it. See if I can move it real quick. There you go. And that's how we got 40 sine 52. From here, you just plug it into your calculator. Okay, so 40 times, well, I don't need that. I'll just hit times. Sine 52. And we get 31.5. Notice it's in degrees. 31.5. I think they just rounded it to 32. Again, follow directions as far as rounding goes. So the kite is about 32 yards from the ground. Okay. Big things to take away. Picture, labels, and picking the right trig. Okay. Boop. Angle of depression. Fun way to remember that. If you're sad, you're looking down. Angle of depression. Hate to make it sound that dark, but you know, whatever helps. Boop. So, an airplane is flying 0.5 miles above the ground. If the pilot must begin a 3-degree descent to an airport runway at that altitude, how far is the airplane from the beginning of the runway? I'm looking for this ground distance. So again, draw a picture. Here's my pretty airplane. Starting a 3-degree decline. Okay, it's 0.5 miles in the air. And we're looking for ground distance, this x, or we'll use d for the ground distance. Okay, I don't think I need parentheses around that. So, I think in class we discussed how if this is 0.5, this could be 0.5. Let me try that again. I don't like that 0.5. There we go. That's 0.5. This is 0.5. This could be D just as much as that D because we see a rectangle. Now here's some interesting stuff. If this is 3 degrees, this too would be 3 degrees right in here. Okay, so you can focus on whichever triangle you want to. Okay, but I got a lot of stuff here, so I'm going to erase some gibberish, make it look neat. For this example, I'll go ahead and just focus on this upper triangle. So I'm going to translate that D up here for ground distance. They should be the same. So with that being said, if I focus on this itty bitty tiny 3 degrees, 0.5 is going to be the opposite side. And distance here would be the adjacent side. Again, I'm using a different slate, so it might be a little slow for us. So, opposite, adjacent, this would be the hypotenuse, but we're not worried about that guy. Barely even wrote hypotenuse, didn't it? There you go. All right, so we would want to use tangent. I already took the liberty to plug stuff in, but a tangent's going to be that opposite over adjacent. Okay, to solve, we need to multiply both sides by D. Let me dress this up. Okay, these D's will cancel. Here's that D, D. I've seen better D's. There we go. Then you're going to want to divide by tangent 3, so those could cancel. And then you're going to plug that in your calculator. So, boop. Plug it in just like I see it, 0.5 on top. Tangent 3 degrees on the bottom. We get 9.5. Indeed, that's the right answer. So, in ground distance, the plane 9.5 miles from the airport. Yay! Let's go look at a couple examples. Really quickly, the fact this boat is looking up at the lighthouse, that's angle of elevation. The fact that if there was a dude up here, he's looking down at the car, looking down at the car. All right, like all examples, I might just, I'm looking at the time, I want to make this video short. We'll just do 2, and I think I'll throw in an angle one if I can find it. So, 24-foot wire is attached to the top of a pole and stretches to a point on the ground. The wire makes a 33-degree angle with the ground. How far is it from the pole to the place where the wire meets the ground? Make a drawing. So, here's the ground. I'm presuming it's like a telephone pole-ish looking thing. Or I guess in this case I just drew a cross, whatever. Anchored, guide wire. Boop. So it's a 24-foot wire. Okay. Makes a 33 degrees angle with the ground. And we need to know how far it is from the pole to the place where the wire meets the ground. So it'll be right there. That's our X. So we're going to let's label this thing. 33 degrees is right here. So X would be the adjacent side. 24 is the height. And the pole would be opposite. Now look, they're not asking how tall the pole is. So we don't care too much about this opposite side. So we're going to focus on a trig function that uses adjacent and hypotenuse. And that's going to be cosine, because cosine is adjacent over hypotenuse. So plug in what you know. So cosine, oh boy, try that again. Cosine, oh man, this slate I borrowed is not really cutting it for this. All right, sorry, I was checking a text message. So adjacent x, hypotenuse 24. And to get the 24 out from there, you go 24 to both sides. Oh man, this slate. I tell y'all what, I think I'm just going to try my luck back at the house. So grab your handy dandy calculator, and you're going to want to go 24 parentheses cosine 33. Oops. 33 parentheses. All right, it's 24 times equals, we get 20.1 or 20.13. Holy moly. Yep. I cannot write that 3. I am going to go home and try my luck on my computer. All right. I'm going to try to find one with an angle, and then I am so quitting this video. Tall cliff. Let's see, 33, 75, 48. Building with blank degrees. What do we got here? Simon stands 140 meters away from the base of the building, of a height of 50.96 meters. Drawing a plan, making an angle depression. Simon from the top of the building with 30 degrees. All right, we're looking for angles here. So let's draw. Ooh, that is not okay. Let's draw ground. Okay, we got a building. A pretty good looking building here. No windows, no doors. Perfect building. Simon stands 140. Okay, 100. 140. Yeah, I am so going home. This thing is barely working. Because like I said, I got my computer working. And if I go home and it doesn't work, I'm going to lose my mind. Okay, from the base of a building height. All right, we got a height of 50.96 meters. All right, make a drawing, marking the angle of depression of Simon from the top of the building. So, if I'm reading this right, it almost sounds like we're looking for the angle of depression right here. But remember, that's the same angle down here. So I'm going to focus on this bottom angle. It'll be the same answer. Focusing on that angle, that means the building here is the opposite side. And this would be the adjacent. And I can only think of one trig function that uses adjacent and opposite, which is tan. And since we're looking for the angle, we got to use the inverse. So plug in the ratio, opposite over adjacent. That's going to give you your theta. So get your handy dandy calculator. And we're going to go, oops, yeah, we need that shift, tangent inverse, fraction key, 50.96 over 140. I'm going to close the parentheses here. We get 20. 20, oh boy, 20. Yeah, I am going home to make the next video because this is hurting me. 20 degrees. You know what? I'm so done. So remember, draw your picture, label, pick out the right trig, plug stuff in, solve for what you don't know. The inverses of the trig functions, remember, are to find angles. All right, I'm signing out. Y'all have a good night.